The second half of section 5.1 is about simplifying radical expressions and solving equations that have exponents. I asked students in class to complete this table and figure out what the numbers were, and I mentioned that you might not be able to do these ones without too much thought. And so pause and take a minute and try to complete this table, and then we'll talk about it after you've tried it. So pause here and try this table. So I know that if I go from 3 to the 1 power to 3 to the 2 power, I would multiply by 3. But if I want to go backwards from 3 to the 3 power to 3 to the 2 power, I would divide by 3. Because 27 divided by 3 gives us 9. If I want to go backwards from 9 to 3, I would divide by 3 again. 9 divided by 3 gives me 3. And by that logic, the next step in the table, I would divide by 3 again, and 3 to the 0 power should be 1. In fact, anything to the 0 power will be 1, because we'll always divide by that number to get what it is to the 0 power. It doesn't feel like it should be true, but it is true that anything to the 0 power is 1. When we continue this pattern, if I divide by 3 again, I don't get a negative number with a negative exponent. I get 1/3. And if I continue dividing by 3, I get 1/9 and 1/27. So what I notice is that the negative exponent gives me the same answer as the positive exponent, except that it's upside down. The number is in the denominator. So negative numbers actually turn our answer into a fraction. So I wanted you to do this activity so that you could see what a positive exponent does. We already know that we just keep multiplying by that number over and over again. That a 0 exponent means that we're at 1, and that a negative exponent turns our answer into a fraction. So 3 to the negative 4th would be the same thing as 1 over 3 to the 4th. I'm going to ask you to evaluate these, and this is just a reminder of yesterday's lesson. What this means is we are going to do the 5th root of 32 first, and then we're going to take that answer to the 3rd power. Oops, I didn't write that very well. I'm going to move it. The bottom number always tells us the root, and the top number always tells us the exponent when we have fractional exponents. So 32, we take that to the 5th root, and then we take our answer to the 3rd power. The 5th root of 32 would be 2, because 2 multiplied by itself 5 times gives us 32, and then 2 to the 3rd power would be 8. We can do this without a calculator. This one is the same idea, except first we're going to turn it into a fraction. So we have 1 over 27 to the 2/3, because that's a negative exponent. And then that's the same thing as 27 cube root, and we take that answer and square it. So that's the same thing as 1 over 3 squared, because 27 is 3 times 3 times 3, and so this is 1/9. The bottom number is the root, the top number is the exponent. For 50 3/4, we would grab a calculator and figure out what that is. And I want to point out that if you're using your calculator for this work, you should raise it to an exponent. So I'm going to do 50 to the 3/4, so I'm going to clear this out of here. 50 to the 3/4, I'm going to type 50. I'm going to type the exponent button, which is above the division sign. And then some calculators, like this one, I don't have to worry about it, but I want you to get used to putting that fraction in parentheses, because some calculators it does matter. So if we put that in parentheses, we get that 50 to the 3/4 is 18.80. This next one I don't need a calculator for, because I'm taking the 4th root of 16, and then I'm going to take that answer to the 3rd power. That's going to be negative 2 to the third power, or negative 8. This one I would need a calculator for, and I recommend rewriting it with fraction exponents so that you don't have to worry about finding weird buttons on your calculator. If I do that, I have 3.4 to the 4/5 power. And notice how I'm putting the 4/5 in parentheses. 4/5 is just 4 divided by 5. And I get 2.66 for that answer. And then this one I don't need a calculator because it's taking the square root of 25. Remember, we don't always write the 2, but we can if we want to. Raised to the third power, so we're doing 5 to the third power, and 5 times 5 times 5 would be 125. The next topic you'll be able to do is simplifying expressions. So an expression is not an equation, it's a thing that has variables and coefficients in it. I have these steps written here, but really the important thing that you should know is that you want to break it up into different parts. So I'm going to look at the coefficient only. I'm going to do the 5th root of 32, and then I'm going to do the 5th root of m to the 15th. I'm going to do those as 2 separate problems. I'm going to simplify the cube root, the 5th root of 32, which I know is 2, and then for the variable part, I'm going to turn my exponents into a fraction. So the 5 is the root that goes on the bottom of my fraction, and the 15 is the top of my fraction. I can simplify because 15 divided by 5 is 3. So this is my answer after I do that. If I had more variables, I would do them as separate roots as well. So this one, you don't have to write this out if it's not helpful to you, but I'm going to see the x's as one thing, and then I'm going to see the y's as a different thing. I'm just separating those out. And I want to point out that we know, because of the way that we define this root sign, that our answer will be positive. We always want the positive root when I give you that sign. That root sign means give me the positive root, if there is one. So when I do this problem, I'm going to get x to the 20 over 4, and I'm going to get y to the 8 over 4, and then I'd have x to the 5th, y to the 2nd. And there's a danger that this might be negative. The reason it might be negative is that y is being raised to the 5th power. And the 5th power is, oh, it might be negative. I just started writing at the same time. The reason that it might be negative is because that 5th power might raise a negative number to a 5th power, you'd still have a negative answer. So what we do is we fix that problem by putting absolute value bars around the x to the 5th. And now our answer will definitely be positive, which is what we want, so that it matches. Be careful if you have an even root, you know the answer will be positive. So if you might have an answer that might be negative, put some absolute value bars around it to fix it. Go ahead and pause the video and try these two, and after you come back, we can go through them together. So go ahead and pause now. So these ones we split into looking at the coefficients and looking at each variable separately. A cube root could be negative. It's okay to have a negative answer. So it's okay for this cube root problem that our answer could also be negative. An even root, the answer will be positive because that's the way we defined those even roots. But after I do the math, I get something that might be negative. So I have to put absolute value bars around x to the cubed to make sure that my answer is positive. Okay, the next skill is solving an equation that has x to a power. And what I want to warn you about is that if you have an even exponent, you will have two solutions, the positive and the negative version. And if you have an odd exponent, you will only have one solution, and it might be negative. So for this one, I'm solving for x. I'm going to start by dividing by 2. I have x to the 5th equals 32. And then the trick is, in order to get rid of that exponent of 5, I'm going to take both sides of my equation to the 1/5 power. So I have 32 to the 1/5 power. We've been doing that all day long. That would be the 5th root of 32, which is 2. Since this is an odd exponent, I don't have to worry. This is the only answer I have. Okay, I'm going to have you pause the video again and try these two problems. These have, make sure you're paying attention to whether you have one solution or possibly two solutions. For these problems, the first one has an odd exponent, so the only answer is 4. The second one has an even exponent, so after you divide by 2 and raise 81 to the 1/4 power, know that you will have the plus and the negative version of those solutions. So it's 3 and -3. All right, we're going to skip this one for now, but I just want to make sure that you understand what kinds of things you should be able to do. You should be able to solve an equation that is x to a power, and the way we do that is by taking that to the reciprocal power. You should be able to translate back and forth between exponential form and radical form. So you should always recognize that the root is in the denominator and the exponent is in the numerator. All right, that is our work for today, and I will see you tomorrow.